Hello guys, welcome back to my YouTube channel. So today we'll see the first type of a queue, that is simple queue. First we'll understand the flow of our program. It is divided into 5 parts. First part is our header files, which includes header files like studio.h, conio.h, and also the declarations of our enqueue, dequeue and display functions, and with that also the maximum size of our queue. Part 2 is our void main function, in which program would take the input from the user and process it. Third part consists of our enqueue function, in which data inputted by the user would be inserted in our queue, and the part 4 is dequeue function, in which the data would be removed or deleted from our queue. And finally the part 5 is used to display the elements of our queue. Now we will understand the enqueue and the dequeue functions in detail. So let's begin with our enqueue function. So have a close look at this algorithm. Firstly, we have to check the condition for the overflow, whether our queue is full or not. And this condition is checked by verifying whether rare is equals to max minus 1. As you know that we are going to perform the queue on the basis of array, that is array based representation of our queue, and you know that array is 0 indexed. So to check the maximum condition, we need to check max minus 1. So here we are going to check whether rare is equals to max minus 1. What this denotes? That whether our queue is full or not, and if this condition is true, the statement would be executed that our queue is overflow, and after that it would exit the loop. So this was our step 1. Now what is step 2? If our first condition is false, that is stack is not overflow, we would check whether our front and rear is equals to minus 1. You know that we are going to declare front and rear as minus 1 initially, and the reason for that is it resembles minus 1 resembles that our queue is empty. So first we are going to check whether front is equals to minus 1 and rear equals to minus 1, and if both are minus 1, this resembles that queue is empty. Then set front is and rear equals to 0, and after that add the element in the queue. And if this condition is false, that is previously we have added some elements, then it would go into the else part. What it would do, it would set the rear is equal to rear plus 1, that is it would increment our rear variable and then insert the data. Inserting the data is done by our step 3, that is queue of rear is equal to num. What is num? Num is the user inputted data, and this equals to is our assignment operator. So the user inputted data is assigned to the queue of rear, and in just above statement we have incremented our rear, so that rear is pointing to the new position in the queue. So on the new position we are assigning the user inputted value. So this is how the enqueue function works. You can see over here in this image, the function is explained. Our rear was pointing to the position of the C. C is our data, right? Now we want to insert this D, and what would happen? First the rear would be incremented, that the rear would point to the position of the D where D is to be inserted, and after that D would be inserted into that. But understand that it is from right to left, that is the numbering is done from right to left. So that front is here and our rear is going towards the left side. So now we'll take a look at dequeue function. Dequeue function is also very simple. If you understand the enqueue ones, definitely you would understand this dequeue function. And if you haven't seen my introduction to queue video, I will provide this in the I button, so kindly watch it and subscribe my channel for more such videos. In dequeue function we would check the underflow condition, and how it is checked? It is checked by verifying whether the front is equal to minus 1 or front is greater than rear. As you know that front is equal to minus 1 resembles that our queue is empty. If it is empty, then obviously it would print the message that queue is underflow. Or front is greater than rear. I will come to this statement. First we'll see the else part. In else part, what is happening? Our queue of front is assigned using this assignment operator to the variable val, that is what is in this front, that is what is the data on the position front is assigned to the variable val, and in the next step we are incrementing our front, and then our if loop is ending and we are exiting the loop. In this image you can see that our front is pointing to the 0th location. After repeatedly performing the dequeue operations, there would be a situation that the front would point to our last element. Okay, so just take an instance that our front and rear both are pointing to the last element, and we are going to delete this last element now. So what our else part says, that queue of front is assigned to the valve, that is the queue of front, that is now where front is pointing to where, to the last element. So the last element would be assigned to the variable val, and after that our algorithm says that front is equal to front plus 1, that is the front is incremented. So front would get incremented, that is front would now point to the position greater than the rear, right? It's quite obvious. If you can imagine, you can see over here in this picture, you can imagine it very well, and if you can't, don't worry, we are going to see this in detail. Okay, so let's see them in detail now. Initially our front and rear is equals to -1, which tells us that our queue is empty. So this is our empty queue. Now what would happen once we perform our enqueue function? If you can remember our algorithm, first we are setting our front and rear both variables to 0, that is both would point to the 0th position of our queue, and then the data would be inserted on the 0th position using our rear pointer or rear variable, not pointer, a rear variable. If you remember our enqueue algorithm, what does it states? Initially, if our queue is empty, that is front is -1 and rear is also -1, then it sets both the variables to 0, that is front is equal to 0 and rear is equal to 0. That is just only for our initial condition when the queue is empty. But when our queue is not empty, previously we have added elements or we have deleted the elements, so then what would happen? It would just increment our rear pointer and then insert an element in our queue. As you can see, rear is pointing to the first position and the 2 is inserted. Now what would happen when we want to insert the next element? First what would happen, rear would get incremented, that is rear would point to the second position, and after that using the assignment operator the data would get inserted in our queue. Just remember this statement, queue of rear is equal to num. What is num? The user inputted data, and using the assignment operator we are assigning it to the queue of rear. What is rear now? Rear is 2, that is queue of 2 would get assigned with the user inputted number or data. So here first rear would point to the second position, and after that data would be inserted on the second position. So by repeatedly performing the enqueue function, we reach to the condition where our queue is full. So let's have a look at this condition. Now our queue is full, that is rear is pointing to the max -1. Now we would perform the dequeue operation. Initially our front was pointing to the 0th position. What would happen if you remember our algorithm? It was set val is equal to queue of front. Now what is front here? Front is 0, and what was on the 0th position? It was number 5. So what would happen? 5 would get assigned to the variable val, and after that statement what was there in the algorithm? It was front is equal to front plus 1, that is we are going to increment our front variable. So what would happen? Front would point from 0 to the first position. So let's try deleting one more element out of it. Again the same algorithm would get executed, that is set val is equal to queue of front. That is what would happen now? Queue of front is now 1. So what is there on the queue of 1? That is the data 2. So 2 would get assigned to the variable val, and after that front would get incremented, that is front would point to the position second in our queue. As you can see it over here, now front is pointing to the second position. After repeatedly performing the dequeue function, we arrive to the condition where our front and rear are pointing to the last variable. Now let's see what would happen if both are pointing to the last element and we are going to delete this element. So first the value that is queue of front, that is queue of 5, and what is queue of 5? That is 9. So that 9 would get assigned to the variable val, right? And after that our front would get incremented. But if you can see over here, maximum size of our queue is what? 6. So basically it is pointing to the 5th position, and after getting incremented our front would get lost, or rather lost, you can say that front would have the value which is greater than rear, right? It's quite obvious. Rear is pointing to the same and front is also pointing to the same, and after doing incrementation of the front, obviously front would have the more value than the rear. And this same condition is for our underflow. If you remember that algorithm, you would get this. And now our queue is empty. So I hope this explanation is clear to you now. Now let's dive into the programming. Let's start programming the queue. So here we are with our online compiler, which is onlinegdb.com. I will provide its link in the description. So let's begin with the flow of our program. Also, I will provide the program in the description, so don't forget to check the description box. So let's run the code. That's great. It is executed without any errors. So let's enter the choice number 1. Okay, let's make it big screen. Fantastic. Enter the element. So let's insert 5. Again I wanna insert now 9. Again I wanna insert 6. Let's see what we have in the queue. So we have 5, 9 and 6. Let's try deleting an element. Okay, so 5 is deleted, and what do we have in the queue now? 9 and 6. Again insert 3 now. Again display. Okay, fine. So it's working properly. Thanks a lot guys for watching this video. Don't forget to subscribe. If you have any doubts, kindly ping me in the comment. Thanks a lot.